Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2017 Time Zone 2. Question number 15. Relate stuff to the topic 14, bonding structure, especially concepts about ozone O3 molecule. Let's see. What can be deduced from the fact that, so here is a really new type, or I can say another classic type of question starting. It's asking for scientific deduction. Right? So remember, when we do anything about deduction, don't just use all of our pre-existing knowledge to handle the question, because we should be deducing it based on the given information. So you will see what I mean. Let's see. What can be deduced from the fact that ozone absorbs UV radiation in the region of 340. So now ozone can absorb UV in the region of 340 nanometers, but molecular oxygen, so O2, absorb at 242 nanometers, right? So what we can observe from the given information is that ozone absorb 330, which is a higher wavelength, and O2 absorb in the region of 242, which is a lower wavelength region. So what we can see from this fact is that, first of all, O3 absorb longer wavelength, while O2 absorb lower wavelength, right? Yeah, and as we have deduced before, right, wavelength is a concept related to frequency, which has an inverse relationship. So which means if you absorb a longer wavelength, that means you need a smaller frequency. And in contrast, O2 will having a larger frequency, right? Yeah, and the frequency is largely related to the value of energy, as there is a direct relationship that energy directly proportional to frequency, while frequency inversely proportional to our wavelength. So that's why here we can deduce smaller the energy, right? And here having larger the energy value. And let's think of it more, right? What is the energy that being used for? Supposedly, if you shine a molecule using a budget of UV radiation, what you are doing is to break a bond, right? So because O3 just requires a smaller value of energy, what we can deduce is from this fact is smaller the energy that is requiring, the weaker the bond that it is being concluded, weaker the bond, right? And obviously more energy is used to break the O2, obviously means they are going to having stronger the bond. So this is all we can deduce starting from the very first beginning, and the very first beginning is only one fact. The fact is O3 absorb a higher, longer wavelength, while O2 absorb a shorter wavelength. But furthermore, can we understand whether O3 is having a delocalization of electrons while O2 is a perfect double bond? This is fact true, but these are the facts that not given from this given information. So can we deduce from only the fact that O3 absorb 340 and O2 absorb 240 and say that the bonds between the atoms in molecular oxygen is double bond? No, we can't deduce based on the given information, although this is going to be a correct statement based on our pre-existing knowledge. So that's why remember, this is going to be a classic way of answering question, or in this multiple choice. Yes, true, this is a correct statement, but this correct statement is not the answer for this question, because we cannot deduce based on the fact that is given. The fact that is given only help us to deduce up to here, right? The here means the O3 is having weaker bonds, while O2 is having stronger bonds between the oxygen atoms. But can we deduce this weaker means because of delocalization? So that's why they have a 1.5 bonds. True, this is what we learn, but this is what we can't deduce from the given information. So we can't say also the bonds in the ozone are delocalized. Again, this is a correct statement, but this cannot be deduced based on the facts given. So that's why B is not acceptable, right? So for C, the bonds between the atoms in ozone are stronger than those in molecular oxygen. This is going to be coming from our deduction, but with opposite result. Based on the understanding of the starting, we deduce at the end that O2 is going to be stronger bonds, but not O3. So you can't say ozone having a stronger bonds, that this is a wrong deduction. Right? Yeah. But for A and B, they are incorrect because we don't know. We don't know based on the given information. Clear, right? So that's why finally D, right? The bonds between the atoms in molecular oxygen needs more energy to break. This is going to be true from the deduction, because starting the thinking mindset from the wavelength, we deduce that more energy is required for O2 in breaking the OO bond than in ozone. So that's why at the end, the answer is going to be D.